Hello, this is video 6.1. We're going to be talking about algebraic expressions. So after today's lesson, you will be able to add and subtract expressions, use the distributive property, and be able to factor expressions. This is coming from EE1 and EE2. Apply properties of operations as strategies to add, subtract, factor, and expand linear expressions with rational coefficients. And understand that rewriting an expression in different forms in a problem context can shed light on the problem and how the quantities in it are related. So let me get going here. Adding and subtracting expressions. Expressions can be added and subtracted to form a combined algebraic expression. How does this work? Well, an algebraic expression, what is it? Well, it's a mathematical phrase where variables and constants are combined using adding, subtracting, multiplying, dividing. So that is this expression. So let's give an example. Jill and Kyle get paid per project. Write an algebraic expression to show how much ABC Advertising Company will pay to hire both Jill and Kyle, who work the same number of hours on the project. So Jill is paid a project fee of $25 plus she gets $10 per hour. So she's getting some base amount of $25 and then she's getting $10 for every hour she works. Kyle, on the other hand, he's going to be paid a base fee or a project fee of $18, and then he's going to get $14 per hour. We want to know how much the company is going to have to pay out for both Jill and Kyle. So we're going to let H equal the number of hours each person works. You can pick any letter you want, but it's good to pick a letter that represents the question that you're being asked and what you're looking for. And since we're looking for number of hours, and that's something that we would want to input, we're going to use H for the number of hours each person has worked. So Jill's algebraic expression will be as follows. She gets $10 per hour, so that's 10 times H, 10 times the number of hours she works. So if she works 1 hour, she gets $10. If she works 2 hours, she gets $20. If she works 3 hours, she gets $30, etc. And then she gets the base fee of $25. So it's whatever hours she works plus the 25. That's what this expression over here, right here, is saying. Now, what about Kyle? Kyle's algebraic expression, he gets $14 times the number of hours he works, plus he gets that base fee of $18, that project fee. Now, we want to combine these to see how much the company has to pay out. So we're going to add them together. So we're going to add the 10H and the 14H. That'll give us 24H, because 10 plus 14 is 24, and then the H is the number of hours, so that has to come along with it, and then we add the base, the project fee, so 25 plus 18 gives us 43. So ABC Advertising will pay $24 an hour times the number of hours plus $43. So we could plug in any number for H that we wanted. Let's say they worked 3 hours. 3 hours. We would multiply 3 times 24 and add 43. So 3 times 24 is what? 72, and then we would add 43, and we would get $115. So that's if they work 3 hours, the company would have to pay out $115. So that's why we write expressions, to help us with our math. Okay, so we have our equation here now. Jill and Kyle work 2 hours. How much will ABC Advertising have to pay for the work? We're going to plug 2 in for H. There's our equation. Let's plug in a 2 for 2 hours. So we do 24 times 2 and then add 43. So 24 times 2 here is 48, and we add 43 and we get $91. So if they work 2 hours, company pays $91. Okay, let's look at another one. Combine the following algebraic expressions. Another word for combining is simplify the algebraic expressions. So here's our two expressions, 3x plus 1/2 plus 7x minus 4.5. So we are going to combine the first set in the quantity of the parentheses plus the second set of numbers in the parentheses. So let's add them up. So we have 3x plus 7x. What's that going to give us? 10x. Now be careful on this next part. We're going to have to add 1/2 plus negative 4.5. Negative 4.5. So that's really a subtraction problem, isn't it? And the answer is going to be negative because the negative 4 is bigger than the 1/2. It's really a subtraction problem. So we can actually cross off the 1/2 because there's a negative 1/2 and a positive 1/2, leaving us with just negative 4. Okay, so that is the combination of the two expressions. Okay, let's do another one. 2x plus 1/4 is in the first parentheses, and then 3x minus 2 1/4 is in the second parentheses. Combine the 2x plus 1/4. Underneath it, we'll write the 3x minus 2 1/4. We're going to add them together. Well, it's easy to add the 2x and the 3x, right? That'll just give us 5x. What about this? We have a positive 1/4 and a negative 2 1/4. So that means we're really subtracting. So we're subtracting 2 1/4 minus 1/4. So the 1/4 will cross off, leaving us just with negative 2. So that answer is 5x minus 2. Let's try another one. 7x minus 4 minus 2x plus 1. Be very careful when you have something in parentheses here and you're subtracting. You have to change the sign of everything in the parentheses before you add them together. So let me show you how that works. You must change the signs of everything in parentheses when the quantity is following a subtraction sign. 7x minus 4 plus, we're going to change the sign, negative 2x plus negative 2. Notice how we changed it to the opposite sign. And now we can add them. So I'm going to add 7x and negative 2x. What's that going to give me? It's like subtraction, isn't it? 5x. And then I'm going to add negative 4 plus negative 2. That should be negative 6, right? So 5x minus 6 is the same as 5x plus negative 6. So you can write it either way. I'm choosing to write it as 5x minus 6. Okay, you get to try some of these. I will see you back in a moment. Okay, welcome back. Let's continue using the distributive property. This is an important concept. We talked about this last year a little. You need to know how to use it this year. You can use the distributive property to remove the parentheses from an algebraic expression. This is called simplifying or expanding the expression. So here we have a 2 in front of the parentheses, x plus 5. So we want to distribute the 2. So we have to multiply the 2 times each number inside the parentheses. So 2 times x gives us 2x, and then 2 times positive 5 gives us 10. That's using the distributive property. And that's your answer, 2x plus 10. Mark is selling tickets for a high school band concert. The band gets to keep 25% of the money he collects from ticket sales to put toward new uniforms. Write an expression to represent how much the band gets to keep. Okay, we need to write an expression. So the adult ticket price is going to cost $16.60. The youth ticket price is $12.20. So we're going to let A equal the number of adult tickets sold. A is a good choice because it stands for adult. And we're going to let, we're going to do that in a minute. So we're going to expression for the money collected. $16.60 times the number of adult tickets sold. Now we're going to let Y equal the number of youth tickets sold. Why did I pick Y? Because it stands for youth. What do you think the expression is going to be for the money collected for the youth tickets? $12.20 times Y. That is correct. And now we're going to add those together. Notice how we cannot add the numbers in front of the letters together because they're different letters. A and Y are different. So we have to write it as $16.60 times A plus $12.20 times times Y. We have to write it that way. We cannot combine these two numbers. Expression for the total money that Mark will get to keep for the new uniforms. Remember up here, he gets to keep 25% of the money. So we're going to change 25% to a decimal. How do I do that? I'm just going to write it here. So we have 25%. The number is after the decimal is after the number. We have to move 2 to the left. So it's 0.25 as a decimal, and then we erase the percent sign, 0.25. Okay, so that's what we have to multiply by. So 0.25 times the quantity, whatever the total money collected is. So the total money collected is going to be this expression right here. And this is going to be the percent that Mark gets to keep. So don't forget to change your 25% to a decimal by moving the decimal 2 places to the left. And then use the distributive property to simplify the expression. So there it is. Let's simplify it. We have to take 0.25 times 16.60A. That'll give us 4.15, and the A comes along. And then we have to multiply 0.25 times 12.20y. That'll give us 3.05y. So altogether, it's 4.15a plus 3.05y. That is how much money Mark gets to keep for the new uniforms. Ta-da! Go back and review this. I would strongly encourage it because this is new stuff for you and you need to understand it. Okay, so now we have our expression for how much money that Mark gets to keep for his uniforms. So we can plug in any number and get an answer. So how much does the band get to keep if Mark sells 20 adult tickets and 40 youth tickets? Well, we're going to plug 20 in for the adult number and 40 in for the youth number, and then we're going to multiply. So we're going to multiply 4.15 times 20. Then we're going to multiply 3.05 times 40, and we're going to add the two answers together. So 83 for the first answer, 122 for the second. We add them together and we get $205. So if they sold 20 tickets of the adults and 40 tickets for the youth, Mark's team would get $205 to buy new uniforms. Okay, here we have a distributive property question. We have to take the 2/3 times the 6e. That'll give us 2/3 times 6e. And we can cross the 3 and the 6 off and cancel them. 3 will go into 6 twice. 3 will go into itself once. And now I'm left with 2 times 2 on top and 1 times nothing on the bottom. So that would result in 2 times 2 is 4, and the e comes along, 4e. Now I have to multiply 2/3 times 9f. So to do that, it's 2/3 times 9f. I can cross off or cancel the 9 and the 3. The 9 will become a 3. The 3 will become a 1. And now I just have left 2 times 3f, which is 6f. And then finally, I have to do 2/3 times negative 21g. So 2/3 times negative 21g. The 3 will cancel in the 7 in the 21 7 times. Negative 7, because it's a negative number. 3 goes into itself once, and now I have 2 times negative 7, negative 14g. So using the distributive property, we end up with 4e plus 6f minus 14g. Try this again. 3a's times the quantity of negative 16a plus 32b minus 24c. Distribute the 3a's to each number. So 3a's times negative 16, and then the a is supposed to be up here, but it moved away. So I must have not made my box big enough. So let's put the a here. Doesn't matter. And get rid of it down here. Okay, so you can cancel the 8 and the negative 16. 8 will go into negative 16 twice, negative 2 times, and 8 goes into itself once. So now I have 3 times negative 2a, which is negative 6a. Now I use the distributive property on the second term. So that's going to be 3a times 32b. 8 will go into 32 and cancel it 4 times, and 8 into itself goes once, and then we can multiply 3 times 4, and we get 12b. And then we multiply 3a minus 24c. So now the 8 and the 24 are going to cancel each other out. 8 goes into 24, negative 3 times. The 8 goes into itself once. 3 times negative 3 is negative 9c. So that's using the distributive property to simplify an expression. Okay, it's your turn. You get to try this. See you back in a moment. Welcome back. Let's continue. Let's talk about factoring expressions. That's the opposite of the distributive property. To factor, a factor is a number that is multiplied by another number to get a product. So if I had 2 times 3 equals 6, the factors of 6 are 2 and 3. When you factor something, or factoring is to write a number or an algebraic expression as a product. Let's see an example. So factoring, like I said, is the opposite of the distributive property. So here we have something, an expression here, 4x plus 8. We're going to factor that. So what number can you divide evenly into both the 4 and the 8? The most you could take out would be a 4, right? So that's what we're going to do. 4 is the number we're going to take out. So divide 4 into each number. What's left stays on the inside of the parentheses. So if I take the 4 out, I'm pulling it out, I have something left in the parentheses, but what? The 4 is out. I have 1x left, and if I take a 4 out of the 8, I've got 2 left. So you see how we used the distributive property before, and now we're pulling it back out and putting it back into the distributive property form. So now this is 4 times 1x plus 2. And usually we just drop the 1. Whenever there's a no number in front of a variable, it's assumed to be a 1. Just like if you had, I forgot what I was going to say. If you had the number 32, for example, you just assume the decimal point is here, but you don't write it. It's the same way with 1x. There's a 1 there, but you don't usually write it. You just know it's there. Okay, let's try another one. Factoring again is the opposite. So we have 2x plus 2. Ask yourself, what number can you divide evenly into both a 2 and a 2? Well, I hope you answered 2, right? So we're going to pull out a 2, divide 2 into each number. What's left stays on the inside of the parentheses. So we're going to pull a 2 out. What's going to be left is an x, so 1x, plus, be careful on this one, 2 divided by 2 is 1. And then we can drop the 1 in front of the x because it's assumed to be there. So the answer is 2 times x plus 1. That's the answer. Okay, let's try another one. 3x plus 9. What number can you divide evenly into both, oops, that's the wrong words, evenly into both a 3 and a 9? I'll fix that. Okay, so I can pull out a 3, and that's the one I'm going to pull out. I'm going to divide 3 into each number. So I'm pulling out a 3. So 3 divided by itself is going to leave me with 1x. If I divide 9 by 3, I'm going to be left with positive 3. So the final answer is 3 times the quantity x plus 3. Again, we drop the 1. It's assumed to be there. Note that if you use the distributive property, you should get the original expression you started with. So let's see, if I was to go back the other direction now and multiply the 3 times the x, I would get 3x, and then I would multiply the 3 times the 3, I would get plus 9. See how I'm using it backwards and forwards. Distributive property is forwards, factoring is backwards. Just showed you is coming up, 3x plus 9. And that's the same thing. So that's what you're doing. Okay, you get to try a couple of factoring problems. See you back in a moment. Welcome back. Let's focus on some higher order thinking. Use the figure to find the product x plus 3, x plus 2. Hint, we're going to find the area. Here's our figure. We're going to find the area of each small square or rectangle, then add the areas of each small square. So these bigger squares are going to be our x's. So area, remember, is length times width. So if we wanted to find the area of just this one square, we would do length times width, and that would give us the inside area. So we're going to call this block X. This is length X. And these will be length 3. Well, there's 3 of them. Each one is one length. So each one is 1. So 1, 2, 3. That's where I'm getting my 3 pieces. Then we have this X. That's going to go right here. That's going to be length X. And then we need 2 more small 1 blocks. So this is length 1, and this is length 1. That's where the 2 is coming from. So now we figure out the area of each inner part. So this is x times x, length times width, x times x, or x squared. So that's x times x is x squared. This one is going to be 1 times the x, right? 1x. This one is also 1 times the x. This one will be 1 times the x. This one here is also 1 times x. This one here is 1 times x. So all those 1x's get added together. 1, 2, 3, 4, 5 1x's. So plus 5x's. And we have a few more things to do. We have to do 1 times 1. There's length of 1, a width of 1. This is 1 times 1. This is 1 times 1. This is 1 times 1. 1 times 1. And finally, 1 times 1. So all of these are 1, 1, 1, 1, 1, 1. Let's put that with our equation. Plus 6. There's 6 ones. 1, 2, 3, 4, 5, 6. So that's how you would multiply to get the product of 2 things in parentheses. There's more things we're going to learn about that, but not right now. Okay, your homework then is on Google Classroom, and I will say goodbye. See you later.